Hello, everyone. I'm Lori Diamond, and I'm the Associate Publisher and Vice President of GovExec's Defense Group. And I'm very excited to be continuing today's conversation with Mr. Kevin Fogarty, who is the Chief Technology Officer for Leidos Defense Group. We're going to discuss the bottom line up front on commercial technology. Kevin, thank you so much for being here with me today.
Awesome. Thank you very much for having me.
Before we get into things, I'd love to hear a little bit about your current role at Leidos and how you got there.
Sure. Yeah, no, I've been with Leidos for about 21 years now. So that actually goes back and predates Leidos, going back to the SAC employee-owned days. I've had a variety of roles, technical roles, program line management roles in our intelligence, defense, and health groups, as well as with Dynetics, right, our subsidiary down here in Huntsville. Recently became the CTO of Leidos Defense Group, right? And that's a very large organization, about $4.3 billion with a portfolio that ranges from cyber security, digital modernization, through C4ISR, multi-domain operations, logistics support, as well as platform development, right, with maritime and airborne platforms. The really neat thing about the CTO role is it's focused on technical strategy, right? So I need to look at where are all sources of technology going, where are customers' missions going, and where do those things intersect?
Well, great. Let's get into today's conversation. So a topic that I foresee coming up quite a bit in this year's Defense One Tech Summit is commercial technology and its impact to warfighters at the speed of mission. Speed is certainly important, but from your view as a global systems integrator, what must the military derive from commercial technology in today's strategic competition?
Sure, yeah, we view speed as a critical thing that commercial technology delivers, but we also like to consider security and scale, right? So combining all three, speed, security, and scale, gives us a differentiator, right, that we can deliver to the warfighter via commercial technology. So on the speed front, right, we often think about how fast commercial industry develops. But one thing I want to highlight is how they can be an enabler in getting technologies to the field, right, rapidly. So, cloud and tactical cloud offerings, not only move data from, the headquarters element down to the battlefield, but they can also be used to move data and applications from industry directly to the battlefield, right? So you're coming right off of your CI/CD pipelines in your development environments and industry and going directly out to the warfighter, right? That is creating tech insertion at speeds we just haven't seen before. Right. Additionally, you can look at how fast industry moves. I mean, if you look at the thousands of Starlink satellites, right, that have been deployed over the past couple of years, providing an incredibly robust and resilient communications fabric, that is something that, again, DoD traditionally and the DIB writ large would not accomplish. So looking at commercial technology, you can take advantage of those things. It has the warfighter's attention. It certainly has our adversary's attention as an enabler. When we look at scale, again, right, a data point, the Chinese naval forces now outnumber U.S. naval forces, right? So our kind of multi-year, multi-decade even procurement programs just aren't going to keep up. So we have to look to the commercial technology to innovate, right? Find us new ways to achieve scale, right? So sticking with the naval example, can we supplement our forces somehow, right? Can we look at those uncrewed systems, right? Things like Seahawk, Sea Hunter, and others to achieve that scale, right? We use smaller form factors, so more of industry can participate in building them. We build them with commercial or off-the-shelf sensors, right? To provide us vision and communications and ultimately can create a higher volume, right, higher number of deployed assets out in the field at a reasonable cost and an appropriate timeline. And then when we look at security, right, the SolarWinds event was a wake-up call for everybody, right? It was when we look at security, SolarWinds was a wake-up call for everybody, right? It was a compromise of the commercial supply chain, right, that trickled into the defense industrial base and our DoD customers. Pivoting from that, right, commercial industry was quick to resolve, right, with patches, threat hunting, even dismantling the adversary's command and control infrastructure. And now we see in the National Cybersecurity Strategy a direction to industry, right? Take ownership of the security of your products, build it in from the beginning, right? And when all those products come with security, that provides a warfighter a inherent resiliency, right, that adversaries can't counter.
As you've said, speed, scale, and security are certainly important benefits for our warfighters. So how does this start getting implemented? And in your opinion, what are some examples of commercial technology adaptations needed for use within DoD systems?
Sure. So one place that we look is the National Defense Science Technology Strategy. This document put out calls for fostering a more vibrant ecosystem that involves complementary processes, right? And those complementary processes, I think, are what's really key here. Those are things that are going to be shared by the DoD and the commercial technology providers themselves. And those processes are going to enable that adaptation or really rapid integration of technologies, right? So again, coming out on the software side, right, to start there, looking at how commercial industry needs to pay attention to and understand and align with open architectures, standards, and frameworks that are put out by the DoD, right? Published interfaces, published data formats, these are all things that the warfighter can take advantage of. And we're seeing it right now in places like space imagery, right? The rapid sharing of imagery over Ukraine and other places allows our DoD decision makers and warfighters access to more reliable data, more data sources, because it's defined, right, in a format that all can consume. When we look at the hardware side, right, the defense industrial base and DoD itself needs to take advantage of rapid prototyping and manufacturing technologies that come from industry, right, specifically additive manufacturing. When we look at some of the complex parts that go into our high-speed weapon systems or other DoD platforms, turning to additive manufacturing, right, and turning to the commercial technology leaders in this space helps us reduce time, right, and get those things to the field quickly. Now, all this has to be checked, right, and that's where coming up with a joint culture of rapid testing, joint demonstrations comes into play, right? How can we quantify the results, right, of commercial technology, the performance of that technology, and validate it before it gets to the field, right? So at Leidos, we have a program called MockTV, right? This is a program designed to increase the cadence of hypersonics testing, right? And it's not just something that we run ourselves in a bubble, right? But this spans all of DoD and a number of commercial partners to see how we can integrate and test and validate systems and subsystems, right, used on our hypersonics platform. So the goal is there to get from, tests 2, 3, 4 times a year down to monthly tests at high cadence using commercially available technologies and seeing how they perform. Some may perform exceptionally well, they go forward, others that don't, we can weed out very quickly. But those complementary processes, right, things that the commercial industry adopts and things that the Department of Defense and the defense industrial base do are ways that we're going to achieve this adaptation more quickly.
So shifting gears a bit, rapid advancement of quantum and generative AI are good reminders that innovation needs to be continual to stay ahead of risk. What's an innovation you're seeing great promise from?
Sure. Well, you named two, and the commercial world is great, right, at creating those foundational game-changing technologies. And that's how we really look at things like generative AI, quantum, digital engineering, those sorts of things. So with generative AI, this is something that we need to take a look at and understand how we refine and update the models, right, that underpin those. We need to inject, warfighter, DoD language, if you will, into them, right? So this is not just a chatbot that you're interacting with, but it's something that understands the lexicon and the relationships in a warfighting in a contested environment, right? And so what we need to do on the defense industrial base side is use those models, to expand into capabilities that the warfighter needs, right? Such as orchestration in a contested environment, making recommended decisions on sensors and shooters to involve in a fight. And these are sorts of things that generative AI can do. It is not just answering the funny questions you ask, but it is providing a distinct advantage to our warfighters. On the quantum side, again, the commercial world is going to drive ahead there in quantum sensing, quantum computing, quantum communications. So if you take quantum computing, for example, the Department of Defense and the DIB are not going to be the ones, Leidos included, are not going to be the ones to develop the world's best quantum computers. That is going to come from commercial industry. What we need to do, again, back to your adaptation point, is understand the technology that's coming out and how we can apply it in the right manner, right? How do we put those computers into an ecosystem, right, that the warfighter can use? How do we route the right data to them, right, to handle the processing? And how do we bring those results back and get them into mission use, right? So quantum by itself gives us speed and fidelity, and DoD and the Defense Industrial Base needs to find a way to get those features into the fight.
So Kevin, how does this all come together? You know, especially when we think about CJADC2 or MDO.
Certainly, yeah. So CJADC2 or combined JADC2 and MDO more broadly are very much about connectivity, right? So connectivity and orchestration of platforms, networks, and data. And at Leidos, this is something that we are all in on, right? We are actively engaging with commercial technology providers, as well as defense industrial base partners on the ABMS digital infrastructure. The goal here is to define business process and models that we can all work with, referring back to those complementary processes I mentioned earlier, and providing systems and digital engineering that create a digital backbone, right, based largely on commercial technology that's open and can be used to accelerate delivery of data and services to aid in decision making, right? In ABMS's case, it's for the Air Force and Space Force. But if we build that open digital backbone, we can expand this to other services as well as our partners in NATO, AUKUS, and further expand the sources of commercial technology we can integrate in, right? Tapping into those other trusted commercial sectors to bring their technologies into the strategic competition. And then ultimately, right, to be successful in this multi-domain environment, the warfare requires those features we talked about earlier, right? Speed, scale, and security. And the thoughtful integration of those technologies into those mission systems is going to create a winning differentiator for the warfighter.
Well, unfortunately, that's all the time that we have today. Kevin, thank you so much for sharing your expertise with us. And thank you, Leidos, for making this event possible. To our audience, thank you for tuning in. We hope you stick around for the next session. For Defense One, I'm Lori Diamond. Have a great day.